Sunlight. We all know it, but honestly, it's one of the most profoundly misunderstood forces of nature out there. On one hand, it's the absolute engine of all life on Earth. It's tied to our moods, our sleep cycles, and our evolutionary survival. But on the other hand, it is a known, incredibly potent carcinogen. So how exactly does our body navigate this paradox? Today, in this explainer, we're going to unpack the hard science behind our complex relationship with the sun. We'll look at everything from the literal chemical cravings happening right inside your skin to the clinical tools dermatologists use to measure your personal risk. So let's just jump right into it. Have you ever felt like you literally need a sunshine fix after a long, gloomy winter? Like you're actually craving it? Well, what if I told you that isn't just a metaphor? Recent neurobiological research suggests that our bodies might actually be chemically addicted to ultraviolet radiation.
Hooked on the sun. Let's look at those chemical cravings.
To really understand this chemical pull, we have to zoom way into the cellular level. There's a specific chemical at the center of all of this, beta endorphin. Here's how it works. When the primary cells in the outer layer of your skin, your epidermal keratinocytes, get hit by UV light, they start synthesizing a protein called POMC. Now, this protein gets processed to create the hormone that gives you a tan, but it also creates beta endorphin. And beta endorphin is an endogenous opioid. Yep, you heard that right. It's in the exact same class of chemicals as morphine. When it enters your bloodstream, it physically elevates your plasma levels and alters your body's pain thresholds.
To see just how deep this hardwiring goes, we have to talk about a pretty wild landmark study published in the journal Cell. Researchers tested chronic, low-dose UV exposure on mice, and they found that this exposure noticeably increased the animals' pain thresholds. They were literally being numbed by those beta endorphins. But here's the crazy part. When the researchers gave the mice naloxone, which is a drug used to block opioid receptors and reverse human overdoses, the pain-numbing effects completely vanished. Not only that, blocking those receptors actually caused the mice to exhibit physical withdrawal symptoms, like the Straub tail response, which is a classic sign of opioid withdrawal in rodents. The mice even went out of their way to avoid areas where they were given the withdrawal-inducing drug. It proved a profound behavioral dependence. So why on earth would our bodies do this? Well, back in the day, this evolutionary quirk kept our ancestors alive. This built-in, addictive reward system for seeking out the sun ensured early humans got enough UV exposure to synthesize vitamin D in their skin, which is absolutely crucial for bone health and survival. But in the modern era, our lifespans are much longer, and intense sun exposure is often just recreational. So this exact same biological drive is now contributing to a relentless, deadly rise in skin cancer. We are quite literally biologically hooked on a carcinogen. Which brings us to Section 2. Starved for light, winter deprivation. Okay, so if our bodies are chemically wired to crave the sun, what happens when you take it away? We see the massive psychological fallout of this in seasonal affective disorder, or SAD. When we don't get that high-energy rush of UV-induced beta endorphins and our circadian rhythms get thrown off by shorter, darker days, our bodies react dramatically. People with SAD experience what are called atypical vegetative symptoms. So instead of just feeling a little down, folks often deal with hypersomnia, which is severe oversleeping. They might overeat, have these intense, pronounced cravings for carbohydrates, and suffer from this heavy, significant lethargy. It's basically a systemic energy crisis triggered by a lack of light. And that brings us to how we actually treat this. There are two really distinct clinical pathways for treating the winter blues. First up, we have bright light therapy, or BLT. This essentially mimics the sun. Patients sit in front of a powerful 10,000 lux light for 30 minutes every morning. It offers a very rapid onset of symptom relief because you're essentially chemically tricking the brain into thinking it's summer. On the flip side is CBT-SAD, a targeted form of cognitive behavioral therapy that retrains the mind to challenge negative seasonal thoughts. Interestingly, studies show that while both treatments are equally effective, CBT-SAD actually proved to be more durable over a 2-year period. So you can treat the chemical deficit or you can treat the psychological response. Section 3. Measuring your skin's risk in clinical dermatology. If sun exposure comes with such severe biological risks, how do doctors actually manage that danger? Well, for decades, the gold standard has been the Fitzpatrick Skin Type Scale. It was developed back in the 1970s by Dr. Thomas B. Fitzpatrick, a Harvard dermatologist. Originally, it was just a practical tool to calculate safe UV dosages for phototherapy treatments so they wouldn't burn patients. You answer a short questionnaire, get a score, and fall into one of 6 types. Type 1 is the palest skin that always burns and never tans, going all the way down to type 6, the deepest brown to black skin tones. And here's a really cool piece of trivia for you. If these descriptions look familiar, it's because the modern emoji skin tones on your phone were modeled directly after this very scale.
But we have to talk about Section 4, the Fitzpatrick Scale's dangerous flaws.
We have to take a really critical look at this, because treating a 1970s phototherapy dosing tool as a universal diagnostic for skin cancer today, it's proving to be quite dangerous. The scale performs reasonably well for lighter skin tones, types 1 through 3. Fair skin folks get highly visible sunburns, the redness, the peeling, which makes taking a self-reported quiz pretty straightforward. But for darker skin tones, types 4 through 6, the picture is dangerously complicated. The scale inherently assumes brown eyes for medium or deeper skin, which immediately skews the results for anyone who doesn't fit that narrow profile. More importantly, redness from a sunburn might simply not be visible on deeper skin tones. This leads to vastly underreported sun damage and creates a false sense of security. It pushes this deadly myth that dark skin cannot get skin cancer. Melanoma happens across all skin tones, and tragically, it's often diagnosed at much later, more dangerous stages in darker skin patients.
And modern researchers are definitely sounding the alarm on this. A 2024 study in the Journal of Clinical and Aesthetic Dermatology found major discrepancies in how providers and patients described their Fitzpatrick type, and it was largely driven by the patient's race. The authors explicitly warned that, quote, extreme caution must be used to prevent the misuse and overgeneralization of the scale. Relying solely on this outdated metric is causing real, objective, and dangerous discrepancies in clinical care today.
Which leads us to Section 5, striking a healthy balance with tailored risk messages.
So, where does that leave us? Health institutions strongly advocate that we need a much more tailored, complex approach. We have to remember that the Fitzpatrick scale captures just one single dimension of risk. Your true vulnerability is highly multifactorial. Your real risk includes things like your family history of melanoma. It includes having a high mole count, usually 50 or more. Did you have blistering sunburns in childhood? Have you ever used a tanning bed? Do you have a suppressed immune system? And of course, your age and the cumulative UV damage you've sustained over your entire lifetime. A person with medium-toned skin, but a family history of melanoma and a past of hitting the tanning bed carries way more risk than a simple skin type score would ever suggest.
Because your risk profile is so unique to you, dermatologists really want you to translate this science directly to your own body. They recommend the highly actionable ABCDE rule from monthly self-exams. It's super straightforward. Check your moles for asymmetry. Does one half not match the other? Look at the borders. Are the edges irregular, ragged, or blurred? Check the color. Are there uneven shades of brown, black, red, or blue? Watch the diameter. Anything larger than a pencil eraser is a warning sign. And finally, evolving. Are you noticing any changes in size, shape, color, or new symptoms like bleeding or itching? This is exactly how you take proactive control of your own health.
So we are back where we started, but hopefully with a much deeper understanding. You've got millions of years of evolution programming you to seek out the sun, and your skin is quite literally giving you a chemical reward for doing it. But that exact same sun carries complex, multifactorial risks that go way beyond a simple skin tone chart. Knowing this powerful evolutionary pull and armed with the knowledge of your own personal risks, how are you going to navigate your body's chemical cravings the next time you step out into the sunlight? Thank you so much for joining me for this explainer, and remember to keep asking questions.